Our need to move defines us. From the earliest migrations of humankind to the intricate global networks of today, transport is the backbone of our civilization. But this freedom of movement comes at a cost. The relationship between transport and the environment is complex and often fraught with challenges. On a global scale, transport systems are major contributors to greenhouse gas emissions, accelerating climate change. Locally, we experience the consequences through air and noise pollution, impacting public health and the quality of our lives. Understanding these impacts is crucial for developing sustainable transport solutions for the future. The environmental footprint of transport extends beyond emissions. The extraction, production, and transportation of fuels themselves have significant environmental consequences. From oil spills to habitat destruction, the hidden costs of our mobile lifestyles are often borne by ecosystems and communities far removed from the convenience of personal vehicles and air travel. The modern transportation sector is heavily reliant on fossil fuels, particularly oil. This dependence has far-reaching environmental implications. The extraction and processing of oil require vast amounts of energy and resources, often leading to habitat destruction and pollution in ecologically sensitive areas. The combustion of fossil fuels in vehicles releases a cocktail of harmful pollutants into the atmosphere. These include carbon dioxide, a major contributor to global warming, as well as nitrogen oxides, particulate matter, and other dangerous compounds. These pollutants have severe impacts on human health, contributing to respiratory problems, cardiovascular disease, and even premature death. The demand for oil also drives geopolitical tensions and conflicts, further highlighting the unsustainable nature of our current transportation systems. As global populations and economies grow, so too does the demand for transport and its associated energy needs. This underscores the urgency of transitioning towards cleaner, more sustainable alternatives to power our mobility. Transport is a major source of air pollution, releasing a complex mixture of gases and particulate matter into the atmosphere. These pollutants have detrimental effects on both human health and the environment. Fine particulate matter, or PM2.5, is a particularly dangerous component of vehicle emissions. These microscopic particles can penetrate deep into our lungs, causing respiratory and cardiovascular problems. Children, the elderly, and those with pre-existing health conditions are particularly vulnerable to the effects of air pollution. Nitrogen oxides, another significant pollutant from transport, contribute to the formation of ground-level ozone, or smog. Smog is a respiratory irritant that can damage lung tissue and exacerbate asthma and other respiratory conditions. It also has detrimental effects on plant life, impacting agricultural yields and ecosystem health. Addressing transport-related pollution requires a multi-pronged approach, including stricter vehicle emission standards, the adoption of cleaner fuels, and a shift towards more sustainable modes of transportation such as public transport, cycling, and walking. The construction and maintenance of transport infrastructure have significant environmental impacts. Roads, railways, airports, and harbors require vast amounts of land, often fragmenting habitats and disrupting ecosystems. Road construction in particular can lead to soil erosion, sedimentation of waterways, and the destruction of natural drainage patterns. This can result in increased flooding, water pollution, and loss of biodiversity. The expansion of road networks also encroaches upon wildlife habitats, increasing the risk of animal-vehicle collisions and hindering the movement of animal populations. Airports, with their extensive runways and infrastructure, require large areas of land and can impact local air and noise pollution levels. The construction of harbors and port facilities can disrupt marine ecosystems, impacting sensitive coastal habitats and marine life. Adopting sustainable infrastructure development practices is crucial for minimizing the environmental footprint of transport. This includes minimizing land use, preserving natural habitats, and utilizing recycled and sustainable materials in construction. Section 5, Shifting the Burden, Externalizing Environmental Costs. A significant challenge in addressing the environmental impacts of transport lies in the externalization of costs. Externalized costs are those that are not directly borne by the users of transport services, but are instead passed on to society as a whole. For example, the health costs associated with air pollution from vehicles are often not reflected in the price of fuel or vehicle ownership. These costs are instead borne by individuals through healthcare expenses and lost productivity, as well as by society through the strain on healthcare systems. Similarly, the environmental costs of climate change, driven in part by emissions from transport, are not fully accounted for in current transportation pricing mechanisms. This disconnect between the true costs of transport and the price paid by users creates a market failure that perpetuates unsustainable transportation practices. Internalizing these external costs through measures such as carbon pricing, congestion charging, and fuel taxes is essential for creating a level playing field that incentivizes sustainable transportation choices. Section 6. A ripple effect: direct, indirect, and cumulative impacts. The environmental impacts of transport can be categorized as direct, indirect, and cumulative. Direct impacts are those that are immediately apparent and easily attributable to transport activities, such as air pollution from vehicle exhaust or noise pollution from road traffic. Indirect impacts are those that occur as a consequence of transport activities, but are less immediately obvious or attributable. For example, the production of steel and other materials used in vehicle manufacturing requires significant energy and resources, resulting in indirect environmental impacts from mining, processing, and transportation. Cumulative impacts refer to the gradual build-up of environmental damage over time as a result of ongoing transport activities. For instance, the continuous release of greenhouse gases from vehicles contributes to the gradual warming of the planet, leading to long-term changes in climate patterns, sea levels, and ecosystem health. Understanding the interconnectedness of these direct, indirect, and cumulative impacts is crucial for developing effective strategies to mitigate the environmental footprint of transport. A holistic approach is needed, addressing all stages of the transport life cycle, from vehicle manufacturing to fuel production to end-of-life vehicle management. Section 7. Navigating the policy maze: controversies and subsidies. Environmental policies play a crucial role in shaping the environmental performance of the transport sector. However, these policies are often subject to debate and controversy, reflecting the complex interplay of economic, social, and environmental considerations. Fuel efficiency standards, for example, aim to reduce greenhouse gas emissions by mandating that vehicles achieve certain fuel economy targets. While such standards have been successful in driving technological innovation and reducing emissions, they can also lead to higher vehicle prices, potentially impacting affordability and consumer choice. Congestion charging schemes, which aim to reduce traffic congestion in urban areas by levying a fee on vehicles entering designated zones, are another example of a policy intervention with both proponents and detractors. While effective in reducing traffic and promoting alternative modes of transport, congestion charging can be perceived as unfair by some, particularly those who rely on their vehicles for essential travel. Subsidies, both for fossil fuels and for cleaner transport alternatives, also play a significant role in shaping transport choices. Phasing out environmentally harmful subsidies and redirecting them towards sustainable transport options is crucial for creating a level playing field that incentivizes a shift towards cleaner mobility. Section 8. A global comparison: energy consumption across transport modes. Different modes of transport have vastly different energy consumption profiles. Road transport, dominated by private vehicles, accounts for the lion's share of global transport energy consumption and associated emissions. Air travel, while responsible for a smaller proportion of overall transport emissions, is the most carbon-intensive mode of transport per passenger kilometer traveled. This is due to the high energy demands of flight and the emissions of other potent greenhouse gases at altitude. Rail transport, particularly electric rail, is generally considered to be a more energy-efficient mode of transport, especially for passenger travel. Ships, while relatively energy-efficient per ton of cargo transported, contribute significantly to global emissions due to the sheer volume of goods transported by sea. Promoting a shift towards more energy-efficient modes of transport, such as rail and public transport, is essential for reducing the environmental footprint of the sector. This will require significant investment in infrastructure as well as policies that incentivize a modal shift away from private vehicles and air travel. Section 9. Greening the engine: technological innovations in transport. Technological advancements are playing a crucial role in reducing the environmental impact of transport. Hybrid and electric vehicles, for example, offer the potential for significant reductions in greenhouse gas emissions and air pollution, particularly in urban areas. Advances in battery technology are extending the range and affordability of electric vehicles, making them an increasingly viable option for a growing number of consumers. Governments around the world are implementing policies to encourage the adoption of electric vehicles, such as tax incentives, subsidies, and the development of charging infrastructure. In addition to vehicle technologies, intelligent transport systems are being deployed to optimize traffic flow, reduce congestion, and improve the efficiency of existing transport infrastructure. Intelligent transport system technologies include traffic management systems, real-time information systems, and intelligent vehicle systems, all of which contribute to a smoother, more efficient, and less polluting transport system. The development and deployment of sustainable alternative fuels, such as biofuels and hydrogen, are also gaining momentum. While challenges remain in terms of scalability and cost competitiveness, these alternative fuels offer the promise of a cleaner, more sustainable future for transport. Section 10. Sustainable transportation: a legacy for future generations. Sustainable transportation is not merely a goal, but a necessity for ensuring that future generations can meet their mobility needs without compromising the health of the planet. It encompasses a holistic approach to transport planning and operation that prioritizes environmental protection, social equity, and economic viability. This includes investing in public transport, cycling infrastructure, and pedestrian-friendly urban design. It means promoting compact, mixed-use development patterns that reduce the need for travel and encourage walking and cycling as viable transportation options. Sustainable transportation also requires a fundamental shift in our consumption patterns, moving away from a culture of car dependency towards a more balanced and sustainable approach to mobility. This includes embracing shared mobility options, such as car sharing and ride-hailing services, as well as teleworking and other technologies that reduce the need for physical travel. Ultimately, achieving sustainable transportation will require a collaborative effort from governments, industry, and individuals alike. By making conscious choices about how we travel, supporting policies that promote sustainable transport, and embracing technological innovations, we can create a cleaner, healthier, and more sustainable future for generations to come.